So you're on YouTube. All right, here we go. So we are up to the last chapter for bivariate data, which is great. In year 11, if you can remember everything we learned in bivariate data, year 11 should be really easy for you. Okay, so I'm talking like your algebra stuff, your equation stuff. Okay, all of those are going to be important still. Make sure you remember it. And if you guys have already forgotten, I did mention that data in year 11 is really long as a subject. Right, Jamie? Okay, you do a 4 hour sack for data. So it's split into two parts, univariate data and bivariate. We're focusing on, yeah, but it's split over your timetable. It's fine. You don't do it all in 4 hours. All right, okay, so bivariate data, but on chapter 9G, we're looking at what we call the line of best fit. Oh, sorry, 9H. Line of best fit. So that's what we're looking at for today. All right, so our intention or our learning intention for today, what I'd hope you'd be able to do is to know how to fit a line of best fit. Okay, when we say fit, as in draw a line that represents the data really well. And the second thing is to predict values using an equation. And what I'm hoping for you to be able to do is obviously all that. So draw a line of best fit, find the equation of a line, and then talk about the prediction that you've made. Okay? All right, let's get into it. If you remember when we started drawing lines in the previous chapter for chapter 1F, 1G, we learned that a graph, okay, remember your graphs have equations, okay, and the equation looked like this, y equals mx plus c. Yeah, remember that. Don't forget this. This is very important. Okay, and this equation, okay, is the equation of a line. Okay, that's what that is. It represents the line. So anyone want to tell me what does M represent? Gradient. Good, thank you, Ecclesia and Jamie. And what does C represent? Good, thank you. So your y-intercept. These are two really important things you have to remember when it comes to lines. Always. Okay, you got to remember it. So here is a line of best fit. Whenever you got a scatter plot, so we're going back to the scatter plots now. Earlier in this topic, we learned how to plot a scatter plot. So you got your x-axis, you got your y-axis, and you got a bunch of dots. Okay, let me see if anybody remembers. Alyssa, how would you describe if the dots are going upwards? Good, and if they're going downwards, they would be negative, okay? How would we describe the strength of a graph? You've got three different ways you can talk about it. Strong, moderate, and weak. Yeah, remember, the more strong they are, the more close they are. And the more weak they are, the more spread out it gets, okay? Now, when it comes to data, what people like to do is they have their dots, yes? But what we want to be able to do is somehow make sense of it, okay? And make a prediction. The idea behind putting a line is so that you can do that. Make sense of it and a prediction on what will happen perhaps in the future of the graph, okay? So fitting a line of best fit is used to represent the data, okay? That's what the line does. It represents what's happening with the data, okay, where the dots are. It can be drawn carefully by eye, which is why it's called a line of best fit. But generally speaking, later on, I think you guys know how to draw the lines. That's generally how you should be drawing it. But for this one, we're just going to be drawing them by eye. So here's some examples of a line of best fit. Anyone know why this is a bad example? The line. Yeah, it doesn't really go with the data, does it? Like the data is here, it should be more like that. Okay? Same with this one. Look at it. It doesn't really follow the data. Okay, it's more straight than it should be with a gradient. And this one here, the line's too high. Okay, so do not draw your lines like this. This here is your ideal best fit. Okay? All right. Keep going. Predictions. All right, so we know how to draw. You're literally just drawing the line as you see, like as a through the data. So actually, before I get into that, if your data looks like this, okay, you've got your bunch of dots. Okay, you can see that it does make a straight line. Why is this not drawing? Okay. Thank you. Okay, and then you draw your line, just like that. Could be better, I think, but don't draw your line like this or like that. It has to represent your dots. Okay, that's the main thing. All right, predictions. Now, if you wanted to make a prediction, what you'd use is the line, okay, where the line is. Look at it. So you've got your x-axis and you've got your y-axis. So generally what you'll be asked to do is make a prediction on the x or the y. So, for example, in this graph, what is y if x equals 2? Okay, so what you do is look at x, where is it on 2 right there, and then go up and see where it hits the line. And then from there, you go to the axis on 5. So it looks like that's the y-axis. So it looks like here, if x is 2, y should equal 5. Okay, so that means y must be 5. Okay, does that make sense? Not too hard, yeah? You're literally just following where it hits on the line itself. So you can start at 2, go up to the line, and you can see that it hits 5. Okay, so there. Let's go to another example. Okay, so here, what is x if y equals 10? So now you're looking at the y-axis, and you're looking at what the x value might be. So if you're at y being 10, so you're at y is there, go there, and I can see that it hits this part of the line. So what is x if y is 10? 6, good. Okay, now if I ask you guys, by the way, what would the coordinate for this be? What's the coordinate for it? Good, that would be 6, 10. And for the previous one, what would this coordinate be? 2, 5. Okay, 2, 5. Watch out for the coordinates, yeah? Thomas, you copying this down? Okay. Let's make some predictions. Okay, here we go. Some more. We can also make predictions using line best fit by substituting values. Again, for the graph below, find the equation of the line of best fit and use to find the value of, okay. So, we need to find the equation now. I think making a prediction like this, not too hard, okay? But now we need to find the equation, okay? So we need to find two things using the equation. What is y if x equals 4? And what is x if y equals 12.5? Now you can obviously see there, if y is 4, okay, so if x is 4, sorry, y would be here, which is there, but we don't know what that value is, okay? So we need to use an equation. And same thing, if y is 12.5, which I assume is here, okay, it should be 8, okay? But let's prove it using the equation. So, what you need to do, okay, when you're doing an equation, remember when you find the equation of a line, you only need how many points? 2, okay? Any 2 points on the line is fine, okay? You remember back to the questions that we did yesterday, just going back here, remember our equation has to look like this, y equals mx plus c, m is the gradient, c is the y-intercept, yeah? Find the gradient, find the y-intercept. Those are 2 things you need to do. Okay, remember this rule we learnt about last lesson, okay, as well. That's how you find the gradient. So, first things first, find any 2 points on the line. It doesn't have to be from the, don't pick points from the original scatter plot. Pick points that are actually on the line itself. Okay, that's the aim here. Pick 2 easy points. According to this, we're going to use 2, 5, 6, 10. So the 2 points are this one and this one. Okay, I could use this one, I could use that, I could use that as well. But we're just going with any 2 points as long as it's on the line. Okay, any 2 points. So let's find the equation. Let's fill this in. Okay, this is what we learnt about last lesson. Okay, and I've split it up into 2. So let's do the gradient first. So remember the rule, y2 minus y1, x2 minus x1. So for the gradient, okay, y2 is 10, y1 is 5, and then x2 is 6, take away x1, which is 2. So that should be 5 over 4. Okay, and you can't really simplify it, so that's fine as is. So the gradient is 5 over 4x. Okay, nothing to it, not too bad. Next is the y-intercept. So far, 5 over 4 is the gradient. I've converted it here to a decimal, so it's the same thing. Okay, so far what we have, okay, is y equals 5 over 4 plus, x plus c. And we're trying to find, remember the y-intercept, which is c. All right, so over to this side now. I need to pick any 2 points. You can pick whichever one you like. Do you guys want to pick a point for me? What's an easy one? 6, 10? Okay, good. Remember, that's x, that's y. Okay, so here, change y to 10, and you're changing x to 6. Okay, so 10, 1.25 times 6, I don't know that off the top of my head. 5 times 6 is 7.5. Yes.
Why is it 1?
Because it's the gradient. It's the same as 5 over. Sorry? It's the same as if I did 5 over 4 on my calculator. Okay, 5 over 4. It also equals 1.25. So you can use either one. Okay, doesn't really matter. Okay, so we're up to now finding C. So if I want to find C, what am I doing here, guys? Good, take away. All right, so it's going to be 10.10, take away 7.5, which equals, should I write that here? 10, take away 2.5, which equals 7.5, 2.5. So our y-intercept is 2.5. Oh, sorry. This doesn't like me today. Okay. There's our formula. 5 over 4x plus 2.5. Okay, so there's my rule. Now I can use a decimal if I want. That's why I've left it as there on the notes. It's the same as 5 over 4, yeah? Don't get too scared of it. So now we just need to make a prediction. So according to this, we need to find out what y is if x equals 4. So using my formula, okay, what is y if x was 4? So you're going to go y equals 1.25 times 4. Okay, what is y if x equals 4? So do it on your calculator, nice and easy. 1.25 times 4 plus 2.5 equals 7.5. So therefore, 7.5. There. Easy. And also, if we check the graph, if x was 4, so if x was 4 over here, you could see that it does hit 7.5 there. So that's what that is. Oh, that's very confusing. Okay, that's that one there. Cool. All right, let's try the other prediction. So according to this, what would x be if y is 12.5? Okay, so the other way now for the second equation. So what would x be? So if y is 12.5, so 12.5 equals 1.25 times x. I'll just leave that as x, sorry, plus 2.5. So now we're trying to find what is x in this regard, okay? So it's the other way. It's the same thing, yeah, you just got to solve it. All right, let me ask. If I'm looking for x, guys, okay, what do I need to move first? What should I move? Good, okay, this is a plus 2.5, becomes minus 2.5. So you get 12.5 minus 2.5 should be 10, equals 1.25 x. What's next? What's next? What's next? I want to find x. Good. Divide by 1.25. Okay, so that means x should be 8. Cool. Okay, 8. And again, if we checked, okay, if we checked on the graph, 12.5 is over here. Okay, so if we checked and got on the line, you can see that it hits 8. Okay. Does that make sense? Not too hard? Yeah, it's not too bad. Okay, you're just converting x to find y, or you're converting y to find x. That's all predictions are. Okay, so all of that just involves finding the equation and then making a prediction using the formula that you're given. Remember, that's the formula that we found from the previous one. All right, next one, interpolation, extrapolation, and this is the last one, and then we'll start doing some exercises. This is pretty easy. Actually, do you guys need to copy that still? Okay, I'm going to move on. All right, next part's pretty easy, yeah? Interpolation, extrapolation. These are probably some new words for you, but this is all about predictions again. Okay, so when you're making a prediction, okay, the accuracy of the prediction will depend whether you're predicting within the range or outside of it. Okay, so when you're making a prediction within the range, so when we talk about within, you've got a bunch of dots and you're making a prediction that's somewhere in the dots, it's reliable and it's called interpolation. Okay, so if you're making a prediction inside the data, it's reliable and it's interpolation. Okay, but if you make a prediction outside the range, so now if you've got a bunch of dots, but you make a prediction that's maybe off the graph or you can't see it in the graph anymore, it's not reliable and it's extrapolation. Okay, so there's two types. Interpolation within the range, reliable. Extrapolation outside the range, not reliable. All right, let's see how that works here. And I've sort of drawn it as a box here so you can see what we're working with here. So if you've got a bunch of dots, okay, right here, and I make a prediction and say, oh, okay, so what's y going to be if x was 12? So if x is 12 over here, I go up and I see my dot is there. Now, tell me, is that within the range or outside the range? Outside. Good, it's outside because the range is only between 1 and I can say 10. So if I make a prediction beyond in the x values outside of 10, okay, it's extrapolation. What if I make a prediction, what is y if x is 6? Is that interpolation or extrapolation? Inter, right? Because it's in the range, it's within my graph, so it's accurate. Same thing with y, yeah? If y was 17.5, for example, and I make a prediction, so over here is where the dot is. Is that inter or extra? Extra, it's outside the range. And my y values, you can see, it starts from like, what's that, 4 all the way up to 15. Okay, so if I make a prediction over here or over here, it's outside the range. Okay, it's not reliable. All right, so let's make some predictions here. If x is 6, y would equal, all right, so if x was 6, so we're looking at the x-axis, and if it was 6, so over here, if x was 6, y would be 10, okay? And 10 because it lines up with that number there on the y. The coordinates for this point, actually let me use green. Okay, what's the coordinate for that point, guys? 610. Okay, don't forget that. That guy there is 610. Okay, and does it ask us, okay, oh, is it interpolation or is it extrapolation? Okay, good. So this is how you would write your answer. In year 11, this is what they want to see. Interpolation. Because interpolation because it is within the range. And some people also write it is reliable. Okay, you want to make sure you include these words here: interpolation, within the range, reliable. Okay, really, really important. That's what they want to see in the actual answers. Okay. So Jacob, can you tell me the difference between interpolation and extrapolation? No. Okay, make sure you're listening. Francis, tell me the difference between interpolation and extrapolation. All right, make sure you're listening, please. Okay, let's make another prediction. If y is 17.5, what's x? So we're looking at the y-axis now. And you can see for y, the limits are around 4 up to 15. So 17.5 is about here. And on the line, there it is. Okay, right there. So if y is 17.5, x should be 12. So what's that coordinate, guys? 12, 17.5. Okay, make sure you understand that. Okay, now tell me, is it inter or extra? Okay, so I would write not a reliable prediction. As it is extrapolation or extrapolating is fine as well. And outside the range. Okay, again, three things you want to mention. Whether it's reliable or not, is it inter or extra, and is it outside and within or outside the range? Three things you got to mention when you do these predictions. Okay, so not too hard, I think, with predictions. In year 12, year 11 and year 12, you get a lot more of using the equation, okay, for predictions. Okay, let's do one more example, then you guys can work. Sorry, I didn't say that last time. All right, last example. You guys ready? Final example. All right, here we go. Worded example. Okay, here we go. Guido wants to know if there's a correlation between someone's age and the amount of hours they spend watching TikTok videos. Okay, and he records his findings below. Question A. We need to construct a scatter plot for his findings with age in the X and TikTok hours in the Y. Comment on the correlation. So remember, when we're talking about correlation, we're talking about the strength and the direction. Actually, let me ask you guys this. What do you think the graph would look like if you looked at the age of a person and the hours of TikTok, the amount of hours they watch on TikTok? Would it be a positive graph or a negative graph? Good. Why is that? Because the older they are, the less they probably watch. I'm going to assume that's the case. Next is we need to fit a line of best fit, so that's not too bad. Use our line to predict the number of hours a person, an 18-year-old person would watch, and then give me a, is this prediction inter or extra? And then based on the line of best fit, make a prediction again on a 45-year-old person. All right, so let's do this. I'm going to pause for now. I want you guys to plot this on the graph there. Okay, all right, so there's your line. Next question. Use the line that you've drawn to make a prediction on the number of hours per day an 18-year-old person will be watching TikTok videos. Is this prediction reliable, or is it interpolating or extrapolating? So if someone was 18, let's look at the age 18. 18 would be like, well, maybe somewhere about here. Okay, so if their age was 18, how many hours of TikTok would they be watching, guys? Roughly. Probably about, I wouldn't say 6. 6 is over here.
Oh, sorry.
What would that be? So that's 5.
5 hours.
Well, if 5 is over here, maybe 5.5. Or 4.5. 4.5.
4.5.
Yeah, well, look at use the line. Okay, this goes up by 2s. Okay, so that means if they're 18, which is about here, they'd be watching about 4.5 hours of TikTok. Is that a lot?
Yeah. Way too much.
Coordinate should be 18. Okay, so based on what we learned about interpolation, extrapolation, this prediction would be what? Reliable or unreliable? Reliable. So it's reliable. As it is it within or outside? So within the range. Therefore, it is interpolation. Sorry. So this is the proper answer you want in year 12. Yeah, that's what they want. Or year 11, year 12. This prediction would be reliable, unreliable. Is it within or outside? And then, therefore, it is interpolation or extrapolation. Not too hard, yeah? Just use the line of best fit to make your predictions. Next one. Okay. Based on the line of best fit, what is the predicted number of hours a day a 45-year-old person will be watching TikTok videos? Comment on this accuracy. Now, where is 45 here in years? Over here. All right, let me just graph it. 45 is over here. If you use the line of best fit, technically, if you try to extend it a little bit, it would be negative, yeah, over here. Negative what though? I would say probably -1. Okay, let's just make a prediction. So if they're a 45-year-old person, they would be watching -1 hours. Now, obviously, that doesn't make sense because you can't have -1 hours, but that's based on the prediction. So as we answer it, this is a what? Accurate or inaccurate? What is it going to be? It's inaccurate, so it's going to be unreliable, yeah? Unreliable prediction because it is outside. And I forgot to include extrapolation there. And therefore, extrapolation or extrapolating. And obviously, you can't have a -1 hours for watching TikTok videos.
So would you still get a mark if you put zero?
No, you'd have to put the actual prediction. Yeah, even though it doesn't make sense.
What's
Yeah.
the correlation?
Oh, the correlation. Remember, is the. Did we not answer that? Correlation is the strength and the direction.
Yeah, bro.
Oh, okay. Correlation should be. Well, what direction is it?
Negative.
Negative, and it looks strong to me. Yeah, so negative strong. If we were to answer. Cool. All right. So, as a recap, guys, remember line of best fit. Okay, you just draw it through the graph, make sure it fits. You can use it to make a prediction. Remember how to find the equation of a line to make a prediction as well. But with the predictions, we can use the line, and remember interpolation within, extrapolation is outside. So remember the difference for both. It's going to be on your sacks. Cool. That's it for 9H.